So today we're talking about water resources in Chapter 9, and then next we'll be doing Chapter 14, which is water pollution. So we have a whole unit on water. The introductory story is about this river right here, which is the Klamath River in the Pacific Northwest, that goes from Oregon down to California. And problems with it are that, well, first, for thousands of years, Native Americans lived on the floodplains on the sides of the river and depended on the salmon that flowed down and up the river. But in the last 100 years or two, many changes had happened to the river. It was dammed. Many farmers diverted the water for their own irrigation. Because of that, Native American tribes were forced from their lands. The salmon industry really went down um, because there was no water. They were pumping all the water out. And finally, in 2009, after a huge loss of thousands and thousands of dead salmon, um, the the company that built the dams decided that it would be more expensive to renovate them, and so they decided to remove them. So they will be removed in 2020, and that will be the largest dam removal in history. So, usable water is rare. 97% of all water on Earth is in the oceans, and so it's salt water and not potable, not drinkable. So notice that not quite 3% is fresh water, and of that 3%, three-quarters of it is tied up in ice and glaciers, which probably due to global warming will be reduced over time, but that's other problems that we'll talk about later. Underground water is another quarter, so underground water being in aquifers, and then surface water, which would be lakes, rivers, streams, wetlands, um, and the atmospheric water make up the surface water. So, not a whole lot that is really available to humans. And that is one of the reasons why you should really read this chapter and see how much water we actually use and how important it is to conserve. So, of that 3%, not quite one quarter is below ground, so groundwater. So, let's talk about that first. Aquifers, as we're really familiar with here in San Antonio, um, are small spaces found within permeable layers of rock. So, it's porous rock like limestone where water can percolate down and be stored. And so those are unconfined is when it's porous rock covered by soil. And a confined aquifer is when you have a layer of impermeable rock or soil on top, as you see here. So impermeable means that that water cannot come down naturally or percolate down naturally in a recharge zone like by rain. It has to find Where's my arrow? It has to find a hole or some kind of opening in that recharge area to actually recharge a confined aquifer. An unconfined aquifer can be recharged by rain. But as you can see, when an unconfined aquifer is closer to the surface, it is much more likely to be contaminated and polluted, usually by human activities. The water table is the uppermost level at which the water in an area fully saturates the rock or soil. So basically, if you look here, the water table is just the top of the water in an aquifer. The recharge zone is where water comes in, and springs come from an aquifer where they will naturally perk up to the surface. So this would be a spring right here. Austin is famous for having Barton Springs. If you've ever gone there and swam, it's a naturally occurring spring. So wells will be dug to be able to pump out water in an unconfined aquifer. They use pumps. However, if you dig a well, a deep well, into an unconfined aquifer, you can understand that there's going to be a lot of pressure as there's a lot of rock on top of that confined aquifer. So once you dig a really deep well, that hole releases some of the pressure, and then the water is able to flow naturally without pumping. And that's a flowing artesian well. Pumping is a really big issue whenever you're talking about groundwater because you don't want to over pump the water. You cannot take out more than is being put back in. And when you are in an area that could be prone to drought, such as we are in San Antonio, it's increasingly important that we conserve our water. And so it's perfectly understandable that we have those days where you can only water once a week, and you should. I don't even water my lawn anymore. It's not worth using so much water to have a pretty green lawn. And I know that that's not the same for everybody. Um, but I just think it's a huge waste when it's just for lawns. If it's for gardens and agriculture, of course, they need water, but lawns, not really. So, when you start to over pump, as in this one here on the B side on the right side, when you start to over pump a deep well, it lowers the water table. That makes sense, especially if you're pumping more than is being recharged by rain. So what that ends up happening, as you see here, is that that leads to the shallower wells to be dry, and so they can no longer pump any more water. So that is a cone of depression. Also, by overpumping, if you're on a coastal zone, which so many cities are built on coastal areas, they're going to need groundwater, so they do pump it. But when you have groundwater that's close to the ocean, as in this diagram, and you overpump, you have that cone of depression, right? And then that will allow salt water to come into the aquifer, and it basically contaminates the fresh water with salt. Sometimes on the AP exam, you could be asked the most random question. And so these are things, these three bullets here are potential AP questions that are really random. They could ask you, what is the oldest lake in the world? That would be Lake Baikal in Russia. It's 25 to 30 million years old. It's also the deepest. The Caspian Sea is the largest in terms of surface area, as far as how large it is, but not very deep. Um, the three largest rivers in the world are the Amazon, Congo, and Yangtze. You do need to know those. Ponds and lakes can be formed three different ways. Well, let me go back. Ponds are typically um, depressions that end up getting filled in, and they're much smaller than a lake. So let's just go with lakes, how they are formed. Tectonic activity. If you have land that rises up um, and can get isolated, then you can have a lake. Especially if it does get isolated from the ocean, it can lead to a higher salinity, be saltier, as in the Caspian Sea. Also, through tectonic activity, you can have a divergent boundary, or when land starts to split apart, which is also a rift, and then water will just fill in that gap, and that's where what happened to Lake Baikal in Russia. Finally, when glaciers start to retreat, they will scrape along the surface, and many times they can carve out giant depressions like craters. And so eventually those will get filled in with water, and that's how scientists think the Great Lakes in North America were formed. This slide is particularly important and does show up often in on an AP exam, though the top and bottom words. Oligotrophic for a lake is basically a new lake, a brand new formed lake. So the water is clear, um, but because it has not been around very long, the cycles haven't been going, the nutrient cycles haven't been going, there's not a whole lot of productivity, so there's low amounts of nutrients. Mesotrophic means there's a moderate level of productivity. but I've never seen that question on the AP exam. Eutrophic is when you have a lot of activity, and so there's a lot of algae, it's kind of dirty, and it's much older. So let's look at those differences. So on the left, you see oligotrophic. Okay, it's still kind of new and fresh. The waters are deep because sedimentation hasn't been occurring very long. Light can get through. And on the right, you have the eutrophic, where there's lots of nutrients from over time as things have come into the lake, as things have died, and so you have nutrients being cycled. And so that, and B, eutrophic lake will go hand in hand with eutrophication, which means overabundance of nutrients. Although the atmosphere contains a very small percentage of the water on Earth, atmospheric water, in which it's 0.03%, so obviously a very little amount of water is in the atmosphere, but we depend so heavily on that atmospheric water to fall as rain in areas. And so um, in many areas, drought can be a problem. Sometimes it's rare and sometimes it's yearly. So obviously there's going to be a loss of human life, of livestock life, of crop life if there is no rain and enough water. Um, they also have long-term effects on the soil. If the soil is not going to be um, moist, it loses its fertility. And over time, that topsoil will start to blow away when it gets really dried out. That's exactly what happened with the Dust Bowl in the 1920s and 30s in the US. It was bad farming practices with them using the same land over and over again, as well as um, transforming grasslands into wheat fields that made the land very erodible. And so when the drought caused the crop failures, that topsoil got blown away by the wind. And then some days the sun was even totally blocked out. In other areas, um, when there's a drought, say like in San Antonio, the main weather thing that we have in San Antonio is flash flooding. And there's several reasons. One, we don't get rain very often, and so we tend to get it in downpours, and then too much water is coming in to allow it to soak into the soil because it's been so dried out. And sometimes when it's so dried out and really hard, it's impermeable, and so it doesn't want to let the water in, and so it'll just run off. That's one cause of our flash flooding. In other areas, um, it's by paving so many areas. It's by development. It's from putting up parking lots and streets, buildings, pavements that make also the ground impermeable, so the rain has nowhere to soak in, so it'll run off. Altering the availability of water. Well, as I said before, lots of communities and civilizations have been built on the edges of rivers or coasts of oceans. And especially in the Nile, they built a whole civilization based on the flooding of the Nile onto the floodplain, which is the land just adjacent to the river. And so when you have that flooding, it brings up that nutrient-rich sediment and water onto the floodplain, which makes it very fertile for agriculture. However, people, in my opinion, stupidly wanted to start developing on this fertile, rich floodplain instead of leaving it only for agriculture. So what they would do was build a levee. And a levee is basically a bank that's built on the side of the river to prevent it from overflowing. The Mississippi River here in the U.S. has the largest system of levees in the world. There's about 1,500 miles of levees to protect the floodplains. The problem, though, is that if you are not allowing the river to overflow, that that nutrient-rich sediment and water cannot go onto the floodplain, so the fertility of the floodplain is reduced, and then all that sediment has to go somewhere. So it'll go downriver and it empties out at the delta of the Mississippi River. And if you've ever seen a picture of the Mississippi Delta, it is insanely packed with sediment, and that is a direct result from the levees being built. Dikes are the same as levees, but they're preventing oceans from getting onto land. Here are two examples of levees breaking. Oops, what did I do? Okay, so two levees breaking, most famously, of course, in 2005 when the levees broke in New Orleans, allowing all that floodwater to come in and causing $80 billion worth of damage. You see here in St. Louis, Missouri, as that levee broke and allowed the Missouri River to flood onto the land. Here's an example of a dike in the Netherlands, and it's actually where two rivers are coming together to the ocean, and so they're trying to prevent the ocean water from getting in there. And one reason why it's so popular in the Netherlands is because so many of their cities actually lie below sea level, so they have an extensive series of levees and dikes to try to block floodwaters from flooding their cities. Dams are also built across rivers or streams to control the flow of water. So they can be used for recreation, they can be used for electricity, for uh, human consumption, and then, of course, for flood control. This picture is of the Three Gorges Dam in China, which is the largest dam in the world. Unfortunately, they had to relocate over 1 million people and flooded some cities that laid behind the dam in the reservoir um, in order to try to prevent the flooding downstream, which would kill, that have killed 1 million people in the last 100 years. So again, the water that is stored behind the dam is called a reservoir. One of the problems of dams um, is that obviously it's going to impede the flow of fish. So what some areas have built are called fish ladders, so that migrating fish like salmon can go upstream, they follow the ladder, and then they can go back downstream if they need to. Aqueducts are also extensive waterways that have been able to carry water to cities that need more, such as New York and LA. They depend heavily on aqueducts, but problems with them by being built with even concrete is that there are lots of cracks and fissions in the concrete, and so you can lose a lot of water just by leaking, and then the evaporation alone. And then also the construction is going to be um, very expensive, and then it disturbs that natural ecosystem and habitats. Desalinization is a way that people have been able to get water, more available water from the ocean. And desalinization is just simply the removing of salt from the salt water so that you can get fresh. And there are two ways of doing it. You can distill it, or you can use reverse osmosis. Mosis. Distillation is simply uh, putting in the salt water into a chamber and heating it up, because as the water turns into steam or vapor, the salt obviously does not evaporate, so it will stay behind. The water is then, or excuse me, the steam is then put into a coil which will condense it back into fresh water, and then they have the fresh water flowing out of one chamber and the briny or salt water flowing out of the other one. Reverse osmosis is simply putting salt water through a filter at very high pressures so that water can go through but the salt cannot. Um, this is a technology that is more efficient, less costly, so more countries could afford it. The problem is, what do you do with all the briny water when you're finished with it? Because you can't use heavily salted water and put it on soil to water the crops, because obviously too much salt um, will damage those crops, kill those crops. But you also really don't want to put it back into oceans or lakes because that makes it over salinated and disrupts the ecosystems there. In the end, they will normally pump all that briny water back out into the ocean. Agriculture, industry, and household needs. So, agriculture is the largest user of fresh water in the world. 70% of water goes to agriculture. And here are four ways of irrigation. And irrigation throughout the world has doubled because of human population growth trying to keep up with food needs. Um, India, China, the US, and Pakistan have more than half of the irrigated lands in all the world. And in the US, we use 30% for agriculture. So here are four ways of irrigation. In furrows, they basically dig these little trenches and fill them with water and eventually seeps out over time to reach the roots. It's only 65%, I guess, yeah, 65% efficient because the other 35% will either run off, not where it's intended, or simply evaporates. The next one is flood irrigation, which you can see in that picture that it's just simply flooding the land in order to let the water settle evenly. You have to be careful with that so you're not flooding it too much because then crops will get waterlogged and that's not good. But it is slightly more efficient by being 70 to 80% efficient. Spray irrigation is another one, simply using basically um, big long sprinklers. And depending on how much water flow is coming out, you can have 75 to 95% efficient. The more leaks that there are, the less efficient it's going to be. Excuse me, just like with your own lawn sprinklers, if you have um, sprinklers built in, a built-in sprinkler system, those often tend to have leaks underground, and so they're very much less efficient. The last one is drip irrigation, which tends to be the most efficient, and that is either running a hose underground, which is the best way because it reduces weed growth because you're not having the water hit the roots from the top but from the bottom. But basically, drip irrigation is just using a hose that drips out slowly to reach all the roots. Hydroponic agriculture is another way of growing crops in which they use a nutrient-rich solution, water, so that they can use the water over and over again, and they don't use any soil. So 95% less water is used because it is reused. Industry is the second largest user of water worldwide, which is 20%, but in the US, we use half of all of our water to generate electricity. And essentially, the water is heated to create steam, which turns the turbines, which turns the generators to generate the electricity. And so we use those in coal plants and we use those in nuclear reactors. And so what's coming out of those nuclear reactors is not carbon dioxide or other pollutants, but it is water vapor. And what happens is that when they do heat up the water, they have to cool it back down. Um, and so when they start cooling it, the water vapor gets released into the atmosphere, and that's what you see. Households are the third largest user of water worldwide, which is 10%, and 10% of all water in the US is used in the household. Um, Notice that it differs greatly between countries as well as in states in the US. Some states use more water than others. It just depends on where you live. But notice that toilet flushing is actually the number one user of household water. And also with household use, like in California, they have more use for outdoor or have more use for outdoor water, like from their swimming pools and being outside more than, say, the East Coast. But definitely know that toilet flushing is the number one water user in households. People can have rights to use the water, but you do not own the water. And so that can get into heavily um, political issues. There are some countries that share rivers that flow through different countries, like with India and Bangladesh. And India wanted to dam up and divert more water to get to their country since it had more people. But Bangladesh is scared, well, if you're diverting more water away from us, then we're not going to have what we need, and we should be sharing. So, water conservation is using techniques in order to, well, conserve water. So, more efficient water fixtures, faucets, washing machines. I'll go back to that in a second. So, for instance, like in my house, I rent my house, but the owner was really nice and got us two of those low flow toilets so that there's one for liquid waste and one for solid waste. Dramatic reduction in the amount of water per flush. I also have the high efficiency washer and dryer, so I use a lot less water than before than with the traditional washing machine. I also have a low flow shower head, so I'm not using nearly as much water as I used to when I shower. But I also don't take very long showers, which is also a good way to conserve water. This is a picture of a house in Arizona where some homeowners were actually paid um, to plant more drought resistant or drought tolerant plants and landscapes. So take a look at some of these water facts. I'm not going to read them to you, um, but notice that there are lots of people that do not have access to drinking water. Over 1 billion people every day, and thousands will die every day from not having access to clean, potable drinking water. One of the problems with the water efficient washing machines is not yet being affordable to customers. And like with most technologies, as it starts to evolve, the prices go down. Look at your Blu-ray players. Blu-rays used to be what, three, $400, like a PS3. Now you can get one for $89, or $59 even, as I saw in an ad today. So that's crazy how cheap that got. Same thing with DVD players. They were a couple hundred when they first came out. Um, and so, like with my washing machines, I was able to actually get them half off. So instead of getting the set for 2000, I got the set for 1000. And that's a huge difference. So I can understand how high efficiency washing machines are not affordable for everyone. Last point is about gray water. Gray water is the wastewater that you get from baths, showers, um, and washing machines. So it has been used, and yes, it might have a little bit of soap and stuff in it, but can still be used to water lawns. And it should be used to water lawns and or golf courses would be a huge user of wastewater. Excuse me, gray water. Contaminated water would be more like the water from the toilet and water from dishwashing machines. One other reason to go vegetarian is that it takes so much water to produce a pound, or excuse me, 2.5 pounds of beef. Water we use, I think it's 32 gallons of water for a kilogram of paper. I mean, that's a lot, which is another reason to conserve paper, so you can conserve water in the manufacturing of paper. All right, that's the end of chapter 9, so let me know if you have questions. Thanks.